right. Welcome, everyone. We have an awesome webcast today with our double A lineup for you. We've got Aaron and we have Alex, A and A. So, what I'm going to do is today we're going to cover Cloudy with a Chance of Stealth for the topic. And we'll go ahead and hop into introductions, but I'm going to hand this directly over to Alex and Aaron, whichever one wants to go first, for them to do their own introductions and tell you a little bit about themselves before we kick into the webcast for today.
Sounds good. Hey, Bill, thanks so much. Hey, guys, Aaron Moss, Senior Security Consultant for Secure Ideas here. Got Alex Rodriguez with us, and we're going to basically talk about how we're using infrastructure as code to create a red team environment so that we can attack your systems. What you see on this title slide right here is our very own Megan Olson, who was a meteorologist, weather girl. I'm not sure exactly what she was definitely in charge of the weather up in Montana. And so we asked her if we could use one of her videos as part of the slide deck and everything, because I mean, Cloudy with a chance of meatballs, Cloudy with a chance of stealth, and that's Cloudy with a big chance of snow apparently up in the passes in Montana. So let's go ahead and get on. I think, Alex, you're next.
Yeah, so I'm Alex Rodriguez. I'm a security consultant, operations, and do a little bit of development work for Secure Ideas. As you can see, I both deploy servers and develop applications to run on them, mainly our infrastructure stuff. And we do that for both on-prem and in the cloud. So the the security consultant part is the hacking stuff. And so my experience is those various tools, which we're mainly going to be talking about Terraform and Ansible, along with AWS today. But just kind of a little summary of me. And I like to listen to a lot of podcasts and contribute to open source.
AWS is where we did most of what we like. We actually performed this for a particular client of ours, which is kind of the reason we're obviously, changing up. All client names will be changed to protect the innocent and guilty. But primarily it was done in AWS, correct?
Yeah, we ended up using a few more Terraform providers than just AWS because you can also control DNS as well as the Google Cloud Workspace through Terraform. So
I'm going to say, so you could use Google Cloud Platform and possibly Azure, stuff like that too as well, right?
Yeah, absolutely. We actually use that to make the Google Cloud Platform and the DNS all set up for our phishing attempts. And then we also used AWS for deploying those phishing servers. So we pointed and configured all the DNS and SMTP stuff to point to our AWS infrastructure for spear phishing attacks.
Cool. All right. Like I said, my name's Aaron Moss. I am based here in Tulsa, Oklahoma. I'm a professional hacker and been doing it since 2017. Professionally been doing it since 2017. Non-professionally, well, we're not going to talk about that. I have been in help desk. I've been IT director. I've been doing consulting for years outside of security consulting. And I am a deconstructed Christian, which means that I believe what Jesus said and not what other people say about the Bible. If you want to discuss that more, please let me know. Hit me up on my Twitter account there, or X, or whatever it's called now. Or you can email me at aaron.moss@secureideas.com. Also, as you can see behind me, I'm a huge horror movie geek. Make my own masks and do all sorts of really cool stuff with it. So if anybody's interested in that, let me know as well. Shameless plug. And I'm a huge headbanger and metalhead. So if anybody likes Slayer, Cannibal Corpse, or Al Green, stuff like that, again, you want to talk about any kind of music at all besides country, hit me up. I'm more than glad to talk about it. So let's talk about infrastructure as code, right? We're going to go over the outline real quick and kind of go over basically what is infrastructure as code, right? What we're talking about is what are we looking at? How do we set this stuff up? What does it do? What are the basics of it? And how can you use this for not only, your any kind of red team experience, but I mean, honestly, you can use this in your day-to-day life as a blue teamer and stuff to just set up and tear down new servers. I mean, quickly. We're talking like ridiculously fast compared to the old time of doing stuff. Now, of course, we're going to be looking at this from the red team perspective of we're trying to use this infrastructure that we're building out quickly to do brute forcing against different servers, to do reconnaissance against other networks, to do the actual attacks and exploits against other networks. And then whenever we get caught, the idea is we could tear that down real quick, put a new system up in the cloud with this IAC, and then continue attacking, and the blue team hopefully won't realize what hit them. Right, Alex?
Absolutely. Yeah, we were planning on doing a live demo, but I realized a couple of days ago whenever I recorded it that it was like 50 minutes. So we'll go into more of that, but it won't be exactly a live demo, but I'll be walking through the different steps that we had done.
The great thing
and
is,
I actually kind of like that you were bringing up the whole doing this as a blue teamer. Honestly, I'm kind of stealing it from the blue team because this is where infrastructure as code kind of started at. That's where the blue team came up with infrastructure as code to have more repeatable and more consistent systems whenever they deploy it. So I essentially am stealing it from the blue team and thinking of it more of a red team perspective.
So what you're saying is we're doing what we do with everything else, where we steal something from blue team and use it for our own advantage.
Ta-da!
Yeah, I love it. Okay, so what is infrastructure as code? Defense Acquisition University, which is a part of the U.S. government, defines infrastructure as code as the automated process of managing and provisioning computer data center resources through machine-readable definition files, rather than physical hardware configuration or interactive configuration tools. Now, that's a mouthful to say, so let's just put it this way. Basically, we've got a bunch of scripts that we're sending through a couple other scripts, right, or a couple other tools that are then going out, calling some APIs, and building these machines out in the cloud, and then configuring them on the fly, right, Alex?
Yep, and we'll get down into more specifics of what exactly infrastructure as code is too. So that's just kind of a higher level perspective. So thank you, Aaron. Cool. So we'll move on to the actual basics of infrastructure as code, or as I like to call it, IAC, just because I am lazy or efficient. Oh, Hayek. You were pronouncing IAC.
Yeah, just ignore me. I'm gonna turn my microphone off now.
No problem. So we're kind of starting out from what traditionally you would have to do whenever it comes to building servers. So before, whenever you're doing physical servers, you'd actually have to rack servers and purchase them and buy all of the different parts of it. But nowadays we have the cloud, so you don't have to do that as much. But now, even with the cloud, you have ClickOps, which is you clicking around in AWS console and deploying things. This is going to be a very heavy AWS talk, but all of this applies to all the other clouds as well. So you're essentially just going through a web UI and deploying those servers. Now, once you deploy the server, you have to configure it. So you're going to have to run commands and manually type in the different commands and figure out what you need to install for each system. And hopefully you're taking very good backups, because if that system ever goes away or you lose all of that command history, you then might have to go back to your 40-page guide for documentation, because that's typically what you would have to, or you would receive from a vendor, or you would make, so that way you can have reproducible builds.
Yeah, I don't miss those days.
Yeah,
even
exactly.
Scripting days where, like where you just have like a Kickstart script or something like that. I still don't miss those days.
Yep, absolutely. Because if one error goes wrong with that script, you have to debug the script and figure out what's going on. And hopefully it's not from your perspective, but it's probably from the vendor's perspective that they screwed something up. So yeah, that's where the next part is. If you were lucky, you were actually able to use a script to provision things instead of manually typing out all the commands yourself. So kind of taking that traditional server paradigm and moving to what infrastructure as code is. We had that brief definition before, well, a little bit less brief than normal, but long story short, Wikipedia had a similar version. But the main thing there is you're provisioning data center resources through readable definition files. And so that can be through a few different types of languages or syntax. Most people have probably heard of YAML, which is white space hell. But similar, yes. But it's really versatile and can be very robust if defined. And it's a lot easier to read than having to write out a full program to run all of the different API calls or other things like that. So from that perspective, you're defining your infrastructure as code. So you're figuring out all the different configuration steps that you need, and then you're typing it out almost like a script, but you're outlining it in a specific human readable format. So that way, whenever the tool that you're using consumes that file, it can actually make the correct API calls or connect to the correct servers and run the different commands needed. So you can kind of think of it as like scripts on steroids, but from an infrastructure as code perspective, there's kind of two different types of infrastructure as code tool. There's technically like a third, but it's mainly these two, which is the imperative versus declarative. And those are, we're going to get more into that, but those are essentially the different types of tools whenever it comes to infrastructure as code. And traditionally, who is infrastructure as code made for? Like I said, we are taking this and stealing it from the blue team, so the sysadmins and the DevOps tools. So we're moving on to why do you need it? And because it's time. It's time for you to stop wasting all of the time in the web UI doing your ClickOps to make sure that your server is deployed as expected. So next. Now we're going to talk more in depth a little bit about what the difference between imperative versus declarative and kind of like a Venn diagram, what they both have. So both allow you to version control your infrastructure. So you can use something like Git or SVN or something like that, some type of source control management. So that way you can version your infrastructure and have it be something that you can contribute with other people with. And that's because they're all in plain text. So, and they're building upon the basic building blocks of that text file to automate the actual creation of those servers through API calls. So your team isn't having to do very much. You're having to create these definition files, and you have that readable infrastructure definition. So that way, then the servers can be deployed in a repeatable way. And so that way you have a consistent and a scalable way of deploying your servers and expanding it out and making your infrastructure very robust, because you can either destroy it, you can recreate it, and it's all very simplistic. You just have to run a few commands on the command line. And in the demo that we're going to be giving, I've actually written wrapper scripts. So that way, all you have to do is run a script like create.sh, and that does a bunch of different commands for you. So that way you can create the system that you're trying to create. So next, we're going to get a little bit more into the differences between imperative versus declarative. So imperative, the nice thing about it is that it's typically easier to learn, because what you're doing is you're being procedural with your steps. So that means you're saying, step 1, I want you to do this. Step 2, I want you to do this. So it's almost like you are writing like a bash script or something. But from that perspective, the difficulty with that is that it leaves it open to configuration drift. And configuration drift means if someone does a manual change on that system, it doesn't take that into account unless you ensure and you program in that to take account. So for example, if I was pushing out SSH keys to a server, and I had my SSH key pushed out to the server, and the only thing I was doing was checking to make sure that the SSH key file exists, then if someone goes in there and truncates the file to 0 lines long, instead of actually fully removing it, whenever my tool goes back through, it'll say, oh, yeah, that file exists, so I don't have to do anything. Compared to declarative is a lot more robust, but it's got a steeper learning curve. So instead of that file getting removed, instead of that file getting determined as okay and continuing, it would say, oh, well, this file's length has actually changed. So you need to make sure that it gets replaced by the string of text that was expected. So moving to more declarative.
Sorry.
You're good.
Thought we were moving on.
You're good. So while it is still easier to define, it's less about your order, and it takes into that configuration drift more. So you write out all of the different steps you want done, and then the tool itself parses all of that information and then interprets what needs to happen first. So instead of you having to outline, this is step 1, 2, 3, you say, give me everything here. And then the tool will say, okay, I need to create these VPC instances first, and then I'll create this EC2 instance. And so it allows you to define everything in a flat file, but then it automatically figures out what needs to happen. So it has a steeper learning curve, and it has something that's called state. And so typically that's how it can identify or determine whenever the local configuration has changed from the remote configuration. And by remote, I mean like AWS or the cloud. So that's kind of a higher level difference between what the imperative versus declarative is.
So would you say that like the declarative side of this would be maybe a little bit smarter than the imperative side, because it actually kind of understands better what you're trying to do rather than you just telling it, hey,
Yeah, it's really nice from the perspective of you don't have to think about as much. You don't have to keep all of that mental state, because it's actually creating a file that contains all of that state for you.
Okay.
Yeah.
So when we were talking about state too, this is something we talked about yesterday when we were discussing this. The state management is also more about like, it's kind of the way I described it, at least in my brain, it was kind of like a virtual hard drive, right? What we're talking about, basically like the actual state of the machine, or like a snapshot that we're looking at, and we're going to try to apply this information to these systems as we go across, right?
Yeah, that is kind of similar, because it allows you to have multiple people be able to interact with it. So that's kind of you can definitely think of it from that perspective, where you take that virtual or that state and multiple people can interact with it.
Okay, cool. So let's talk about leveraging IAC for our red team exercises. Now, again, this is one of those situations where from the red team, we're attackers, right? Like that's the idea. We're looking at how we can break into your network or whatever else. And in this case, of course, we're talking about networks. I very seriously doubt that we're going to be trying to break into a physical location with anything like this. But with AI, anything's possible. I'm just going to throw that out there. Just, we're going to speak that into the ether. But our perspective is we need to be able to repeat our the same red team exercises, as far as like the same attack measures, the same recon measures, all the different pieces and tools that we have. We need to be able to repeat these over and over and over again for each individual server or network or whatever else it is we're attacking, because much like with the blue team, a lot of what we do is really the same stuff over and over again. It's just figuring out how to manipulate it and configure it and tailor it really to the specific server that we're looking about, right? So
yeah, and on that, actually, this was the second year that we actually did this for the client. And the funny thing is I created this for the first engagement, and I was able to pretty much pick it up almost exactly how it was from the first year. And the second year that we did it, I almost had to change nothing for it. So that just speaks to the repeatability of it.
Also to the scalability, right? Like with scalability, we need to be able to basically scale this out to, hey, if our client has grown in size, right, then we need our infrastructure to grow in size as well. So the scalability and everything, we're able to basically say, hey, we want this number of servers and increase that to whatever. And of course, the only thing we really have to worry about at that point is what? Paying AWS for the number of servers and the sizes we want, right? And so From there, it's about what kind of tools can we use? Well, that's where Alex comes in with, and of course, whenever I look at this, I'm thinking, our tool sets like Responder and Nikto and GoBuster or whatever else. And it's like, no. What tools can we use to actually implement this in the cloud so that we can then use those tools to install the other tools. Right, Alex?
Exactly. Yep. Yeah, so this is kind of our example of what we had for the engagement. It was a black box test for around 2 months. And that
You want to
extended
define
time
black box
frame.
test for anybody out there who doesn't know?
Oh yeah, good idea. So a black box test, instead of working with the client to enumerate, or they give us domains or IPs that are in scope, we have to essentially come from a no knowledge perspective, and we have to try and figure out how can we get into this organization, and how far can we get once we've gotten in. So that's kind of where the more red team engagement compared to a pen test.
And if I may interject, go ahead.
No, go ahead.
I was just going to say, basically, the idea behind a black box assessment is we're coming at this from the perspective of an actual attacker that has little to no information about the company whatsoever. And we're trying to figure out exactly what we can do to break in, right? Most attackers, whenever they attack, especially, we're talking criminals, right? We're not talking about like, professionals that are paid to do this as far as like contractual work, legally speaking, authorized pen testing, right? We're not talking about that. We're talking about the attackers, maybe nation states or ransomware groups or whatever else that are out there. They take their time, typically speaking, with a lot of different scenarios to do research on their company and try to figure out, okay, we're going to be looking at this to see what entry points may be available, where we can attack, what's going to get us the most bang for the buck, etc. Right? And so we're looking at this from that same kind of perspective. The thing is, with a lot of our black box pen tests, the reason a lot of our clients don't necessarily do it is because it does take a lot more time. That's the reason we have that 2-month time frame. Typically speaking, for most of our engagements, when we're looking at just doing penetration tests or something, it's typically only like a couple of weeks. So to extend that out to 2 months costs a lot more because we're having to do a lot of reconnaissance, having to talk to a lot of people. There may be some social engineering involved, stuff like that, right? So, but that was the idea with this. They wanted to see, hey, from the perspective of somebody who knows little to nothing about the company, where can you go, right? That's the reason we have this infrastructure set up and everything, because the blue team is very active, right? They're watching for all kinds of attacks. They're watching for any kind of brute force attacks. They're watching for any kind of nmap scans, network scans, or anything like that. And like Alex said a while ago, this is the second year that we've done this. So they kind of maybe had an idea of what they were going to be looking for. Whether or not they knew we were coming was going to be up to their management team that signed off on the contract. And we just tried to be as stealthy as possible, right, Alex?
Absolutely. Yeah, we actually demonstrated multiple times or identified how if we stayed too long in a particular external IP address and we were scanning for an extended amount of time, we actually would get blocked and we wouldn't be able to access certain ports for those servers anymore. Yep. And Aaron was actually on the engagement with me, so that's why he's able to talk so much about it as well, because we were both on the engagement.
I will say I didn't set any of this infrastructure up. I just got to use it and everything. So I'm not an IAC guy, but I do play one on TV.
But yeah, so whenever we're having to rotate our external IP addresses quickly because their blue team is so active, the easiest thing for us to do is use something like AWS. And if we're going to deploy servers on AWS and we're having to rotate the IP, the only way other than IAC that I can think of that is like you turn off the instance, you copy the hard drive over to the new EC2 instance and then boot it up with the same hard drive. And that was just not super enjoyable, especially because I was the main one that kind of supported whoever else was on the engagement. So I was the one kind of trying to ensure whatever they needed. I also did the testing, but whatever they needed, I tried to spin up and make sure that, hey, if you stay here too long, all right, let's move on to the next IP the next day or something like that. So how do we kind of transfer whenever we do rotate IPs and we're destroying and recreating an instance? How do we carry over the state or the scans or anything like that were left on that server. And what's the easiest and most agile way to do that? And that would be through infrastructure as code, or IAC. So my personal opinion about how I see most people in general, but most red teamers, or pen testers, what they'll consider IAC is something like using a single tool to provision the entire infrastructure. And while it's easier from the perspective of not having to learn multiple tools, it also inhibits you because you're not able to be as agile and have your configuration and provisioning be as efficient as it can be. So for example, the kind of methodology that I was talking about before with imperative, the tool Ansible is mainly an imperative tool. And I'll see a lot of red teamers and other people talking about how they use Ansible to deploy EC2 instances on AWS. And while technically, yes, it can do that, it's kind of fitting a square peg in a round hole. So in my personal opinion, there's kind of a separation between the actual deployment of infrastructure and the configuration of the infrastructure. So the deployment of the infrastructure is a lot more easier to do with something that's more declarative, like Terraform or OpenTofu, which is the open alternative to Terraform, or is the more open alternative to Terraform. And then the actual provisioning of those servers is best served by a more imperative tool that can communicate over SSH, like Ansible. So that's kind of my personal opinion on where I've seen some people in the industry kind of make a different choice than I personally would have. But I think we can move on to the demo if you don't mind introing it.
I do mind it. Oh wait, no, I don't. No, I don't. I like the introing stuff. That's right. Yeah, we were going to have a live demo, like Alex said earlier, but that demo itself was going to take almost an hour to actually perform. So we actually, just to be on the safe side, went ahead and recorded a demo that we're going to talk about. The actual demo itself, if you want to view more about it, I believe you can actually, there's a script here, correct, Alex, on our Professionally Evil GitHub?
Yeah, so that GitHub repository is actually all of the code that's going to be used in the demo today. So we'll be able to provide you the slides, or you can always visit it yourself. But all of the files that I'm demoing from the live demo or the video recorded demo will actually be the exact same slides in that repository. So while it was almost an hour, I did want to kind of caveat, in that 50 minutes to an hour time frame, I was able to create 5 EC2 instances. I was able to provision them all, and 2 of those were Nessus installations, and 3 of them were Kali complete full upgrades, which can take typically like 10 minutes just to run those.
Just
so I was
packages and install
exactly. So I was able to do all of that inside that 50-minute time frame. So I also was able to provision all of the supplemental resources you need in AWS. So your VPC, your subnet, your security groups, pretty much everything that you end up needing for allowing your server to communicate to other things and allowing you to communicate to your server in a secure mechanism.
So what's a VPC?
Good call out. A VPC is a virtual private connection, but essentially it's an AWS network. So it allows your EC2 instances or your servers in AWS to communicate to the internet.
Okay.
Yeah. So along with all those supplemental resources, I also was able to bootstrap all of the infrastructure so that way anyone from your team can contribute, and kind of, as long as they understand how these tools and methodologies work, they can modify the files, apply it locally, and it'll ensure that no one else is writing or trying to provision the same thing. And that state is kind of more decentralized. So that way it's easier for multiple people to be able to contribute to that. So let's go ahead and get onto the demo. And I will share my screen. Share screen, window. And here we go. There you go. I think you should be able to see it now, correct?
Yes, sir.
Cool.
Windows 95. Whoa.
That's my host name for my Linux machine that I have for work.
I love that so much. You weren't even born in 1995, I don't think. Were you, Alex?
No comment, but I was very close.
Bill, if you're there, we're old, buddy.
I hear you. I hear you.
So, this is the video recording of on the left-hand side is my VS Code setup, and then on the right-hand side is our AWS account. And the first thing that I'm going to show you in the video is that there's nothing in. Whoops, I was playing it at very fast speed. Sorry about that. There's nothing in our AWS account on the right-hand side for this webcast. So these extra instances here are for our Active Directory class. So I couldn't get rid of those, but you can see that there were no EC2 instances there besides those two, and then there are no buckets that are called SI Webcast Terraform State Cloud, which is the bucket that we're going to end up using to manage the state. So next, I have a Docker container that I'm running to install all of the dependencies, so that way you don't have to worry about making sure you have AWS CLI, Terraform, Ansible all installed. All of this is self-contained inside of a Docker file that's inside that repository. So you can run this exact same command or swapping out Podman for Docker on your machine if you have it installed and be able to get the exact same environment that I had whenever I was running this demo. And I think, Aaron, you had mentioned that you had just recently had some more encounters with Docker, right?
I did, actually. I just learned how to use Docker just in the last few months because Corey, one of our other consultants here, kind of helped me understand some stuff with how he builds stuff out. And I've only recently realized how really powerful Docker is. And from my understanding, basically what we're doing here is kind of like Docker on steroids. Correct?
Yeah. Yep. That is similar. So this is kind of a brief caveat that I put, just to let you know. I configured my AWS CLI, and I created an SSH key in my local directory. And then I have a tool that's called dirinv, which loads environment variables. And I'm showing you the password because this is a very bad password, and you should choose a better password. So whenever you actually run these, you don't have to do it this way. It'll actually prompt you for a Nessus password and license, but I didn't want to, of course, display our Nessus license or passwords, or at least Nessus license. So this is the way I was doing it.
You mean Nessus licenses?
Yeah, exactly. So I'm initializing the Terraform state for this folder called S3 state. And I'm going to kind of run these commands, and we'll go over these files like as needed or in retrospect for the commands, because sometimes the time takes a little bit longer. So this is me running Terraform apply, which then creates an S3 bucket and a DynamoDB table, which the DynamoDB table is to kind of help ensure that you have that extra protection or whenever you go to modify your Terraform state. And right now, the Terraform block up top, this is, sorry, I should back up. This is called HCL, or HashiCorp Configuration Language. And so it's a particular type of markup that Terraform uses to read all of the config files. Essentially, it's the config file for Terraform. So you outline what you want for Terraform to do in this language or this markup, essentially. And then it reads this file and understands, okay, you want to have your Terraform state in a backend S3 bucket. Right now it's commented out, but I'm getting ready to uncomment it. So that way it migrates my local state to a remote state, which allows multiple people to interact with it. So that's what this step is doing. So we're migrating our local state so that way not just us, but everyone else on our team can kind of contribute and ensure that they're not stomping over other people's feet whenever they do this. So now you can see we were able to create the bucket, and now we're inside the bucket on the right-hand side. You can see that there's actually no files in there yet, though. So we're getting ready to run a command that is going to do the migration that I had mentioned before. And that'll take our, I do Terraform apply just to show you. It warns you and tries to make sure that you don't mess things up. Because you did change a backend configuration for Terraform. So it says, hey, you probably need to migrate this because this is important to migrate. So I typed yes, I accepted it, and then now your Terraform state is up in AWS S3 without you having to upload any files or anything like that. Terraform took care of everything for you. So now I'm going to auto-apply the S3 state file just to make sure that everything is in sync. We had a change there. You can see that it was a change because of this yellow little squiggly line. And so instead of it being the green that we had seen before, you can see that it's changing from true to false for this force destroy. And that was because I had commented it out lower, because we'll end up using that in the future, but we don't need it now. So, and you can see that it's telling you it's modifying the state and sending those API calls to AWS. And now the apply is complete. And one thing has changed, but nothing has been added or destroyed. And that's the really intelligent thing about that declarative style that I was mentioning before, because you're able to make incremental changes instead of having to do whole cloth replacements. So now what it's doing is it's actually downloading what are called Terraform modules. And there's a bunch of modules that people have created, and there are official support for even like AWS modules. So that way, what I end up using is this AWS module to create all the VPC or that network in AWS. I use that, and I'll end up showing it in a little bit, but it's probably no more than like 10 lines. And so you can kind of think of modules as like functions. And so you provide parameters or you provide options for that function to execute with. And then that takes your shortened amount of configuration and then expands it on the back end to have all the information you need for it. So from this, it's just initializing. So it downloaded all those modules during the initialization process. And we're going to do the apply here in a second, and I'll show you all of the different configuration options I put in the file end up expanding out to 39 different resources in AWS. So imagine if you had to go through and manually configure all 39 different resources through ClickOps. You can see 39. And ensure that you do that consistently every time you need to do a red team engagement.
So you're talking about resources. Can you elaborate on the resources you're talking about?
Yeah, so the resources are kind of what it's showing here a little bit. It's the VPCs, it's the security groups, it's the various things inside of AWS that need to get created. They're broken down into little parts that are called resources. So you can provide configuration options for how you want to configure each resource. But each of those different things, the VPC, which is the network, your security group, which is your local firewall, all of that stuff is broken down in what's called resources, which is then what ends up getting provisioned for API requests in the backend. So you outline all the different resources you want, and then Terraform converts all of those files declared for resources to the API calls that AWS needs. That's a very good question, though, because I did not clarify what that is.
No worries. Like I said, if I'm asking the question, it's because other people probably have the same question. So that's a good answer.
Absolutely. Yeah, and you can see it's creating subnets. It's creating routing tables, IPv6 things. It's creating security groups. And it tells you as it's creating all of them and how long it's taking, and if it's still creating over an extended amount of time. And then whenever creation is complete, it says creation complete. And then you can see these are kind of the outputs that we're then going to use inside of the rest of our Terraform files to make things more reproducible. So the main VPCs is we're going to deploy our servers. The prod key pair is our SSH key that got deployed to AWS. So now we are moving back up into the main directory, and we're creating a specific folder that's going to essentially handle our state as between the different servers. So this folder is going to be the point where we're rsyncing or sending files back and forth between the remote server and our local machine. So that way, whenever we want to ensure everyone has the information from the previous server, it gets synced down to our machine first and then back up to the cloud. There's more efficient ways you can do it, but this was simple enough and it worked for us.
And this is what we talked about earlier, the state or the snapshot virtual hard drive type
Exactly.
Right?
Yep, that's exactly right. And right now I'm using a tool called pipenv to install our Python dependencies, which is going to include Ansible and other things. And I use pipenv so that way it's kind of more pinned to a specific version, so that way I don't have to worry about something changing out from underneath me. And then Ansible, that command that you had seen there, is now installing various collections and roles, which are essentially like functions for Ansible. It allows things to be more reproducible and allows people to create little functions for you to reuse inside of your code. And that way you don't have to create the wheel every single time. So put the caveat of typically you would get prompted for your Nessus license whenever you run this create script, because that's just the way the playbook is configured. But because I didn't want to disclose it, it's using the environment variable. So now as that's deploying in the background, we're going to kind of go over the various things that have been deployed so far. So this is the VPC that I was discussing, or the network in AWS that I was discussing before. You can see that there's the enable NAT gateway that allows your systems inside of the VPC to communicate to the internet. There's enable subnet IPv6 prefixes, enable DNS hostname. So these are the various configuration options or the parameters you're sending to this VPC module. And you can see that it says module on line 37, it says module VPC. And that's where that function that other people have created is getting reused inside of my config file. And so it's, let's see, 37, there's a lot of white space and comments for that. But there's around 30 lines there, and I'm able to deploy an entire VPC without having to manually configure all of that myself. So now we're going over to where the Nessus Terraform code gets done, and you can see there we already have a public IP address. So our EC2 instance has already been deployed, and we have a public IP address for that. Now we've finished the Terraform state and moved over to the Ansible state. And so you can see that where it says finishing T create, T is Terraform, and then starting A create, which is Ansible. And so this is the server that it's applying to. So we finished Terraform, but we're going to review Terraform while the Ansible is running. And it's moving over to the Ansible state. And we have a step in there. Oh, go ahead.
I was just going to ask, so this is the Nessus server that we're setting up, right? And there's 5 servers total. So 2 Nessus servers, 3 Kali servers. And this is just the Nessus server itself, right?
So there's only going to be 3 servers, but we're going to recreate the Nessus server and one of the Kali servers to demo that you don't lose the information that gets brought back down to your machine. So that way you don't lose that state between the servers. That virtual hard drive.
Okay.
Yeah, so we're going to intentionally destroy them, show that they grabbed a new IP address, which demos our use case of grabbing a new public IP address, and still everything gets configured in the end.
So we're getting close on time at this point. Is there any way we can kind of speed this up towards the end to kind of see the end product?
Yeah, absolutely.
Or is there any other steps that we need to see in the meantime?
Yeah, there are, let's see, there's a few. I can go ahead. There's this little wait step in between, so that way your Ansible instance can actually get provisioned. Then we've got, I've actually created some Terraform modules of my own in the repository. And this allows us to say, hey, I want an Ubuntu server deployed, or hey, I want a Kali server deployed. And that's what we end up specifying inside of the Nessus file, which I'll jump back to. So this is our Nessus Terraform file, 10 lines, which outlines, hey, give me an Ubuntu server with this instance size and this disk space, and I want IPv6, please. And then it says, okay, I'll use this module that I'd created and is in the repository. And from those 10 lines, it's able to spin up an entire EC2 instance for us. So we go through, that's the module. You can see the server is getting updated and running a reboot. We're then going to cover the actual provisioning. And the actual provisioning for the Nessus server is just this playbook pointing to another playbook. So that way we can reuse that playbook multiple times. And this is where it actually does the prompting of your license, installing Nessus. And in this instance, we're actually using Docker to deploy Nessus because you're able to pass environment variables and it makes it more reproducible that way. So we're going over that and breaking into more of the building blocks. And this is almost done, and it's done now. So you can see the output of my playbook points us to where the Nessus instance is at. And we're going to copy that and paste it over. And you can see it's initializing the plugins.
So basically, everything that you just did essentially installed the new server, spun the new server up, installed Nessus, and got everything running on it already, right?
Yep, and all I had to do,
security groups and everything else, and all we have to do is just use it.
Yep. Well, there's the initial Terraform apply, and then once I CD'd into the Nessus folder, all I did was /create.sh, and it created everything for me. It ran all the Terraform, all the Ansible commands in the background for me, because I have those just kind of abstracted away, so that way you don't have to worry about it.
So is this video going to be available on the GitHub as well in the repository, so that if anybody wants to go back and watch it, they can kind of go through step by step and see how you built it out?
Yeah, I don't know if the repository will house it, but we can probably host it on our YouTube.
Okay.
This was also kind of me rough cutting things together, so I'll get to the point where it's actually got the 3 different servers deployed, and we ran a scan on here, so that way we can demo transferring that state or the virtual hard drive. And you can see we have a new Nessus instance with a new external IP address. So that demos that use case of grabbing a new IP address, and all I'm doing is running a /recreate.sh, and it's handling creating all of the different servers in the background, and it's creating all of those servers for me, and all I have to specify is the folder in that script.
That is a beautiful thing you've done there. That is
and you can see this is a completely new server, and the state transferred between the actual servers.
That is really cool.
And now I'm going to just demo. It's close to the end now, but this is demoing destroying everything. So now we've destroyed all the EC2 instances. We've destroyed all the other 39 resources we provisioned initially. And now we're going to destroy the S3 bucket. And this demonstrates that not only do you have the reproducibility to deploy whenever you want, but you have the cost savings as well of once you're done with the engagement, you can wipe out everything that you created. So you don't have to have that extra high excessive AWS bill because you had things running longer than they needed to. So
I think you're just speaking to all the managers at this point. It was like my budget. Like that's an awesome thing in and of itself right there, because budget is super important.
Yeah, absolutely. There you can see
the
the
bucket
is
named
destroyed.
blah 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 webcast can't be found.
Yep,
it's
it's
gone.
been destroyed.
Fantastic.
All right, and then stop sharing screen.
So I'm going to bring up the presentation again real quick. So as you can see here, this is where the live demo, all of the data is at for the live demo. It's in our Professionally Evil GitHub repository. So if you go to github.com/professionally evil, you can see all the different public repos we've got there and take a look at that. So some other practical examples that we've got, right? So the C2 infrastructure. You want to talk about that real quick?
Yeah. So the Red Team Infrastructure Wiki is a wiki that kind of outlines how you can deploy your C2 infrastructure. And that's all manual. It's almost like a documentation place for how things can be deployed, compared to the next two are actual blog posts by Rostamaus. And these are the Wayback Machine links for them because his blog has changed. But these were some blog posts that I had seen before, which were really awesome because they take the C2 and the Red Team Infrastructure Wiki and put them into Terraform. And so that's a practical example of taking something that's well documented, industry standard, and then codifying it in your infrastructure as code so that way it's reproducible. And that way many people can use it instead of just you. The next thing that we're kind of covering is that, so the first image is the C2 or the Red Team Infrastructure Wiki. The bottom right-hand image is actually a diagram that I created for how you can automate the building of your Kali images. And I actually did a workshop on it, and both those links are there. But it allows you to, we talked about before how Kali updates are just extremely long and take forever. Yeah. In my scenario, I was actually using it for students. So I was at a university helping out a cybersecurity organization, and they would have students come in, and we would have at the beginning of the year a Kali install fest, essentially. So we'd walk people through how to install Kali. But if someone misses that first meeting and they come to our second meeting, they have to walk through the entire Kali install again. And they have to take 10, 20 minutes just for the updates to download and install. So to address that, I created a pipeline that would automate the process of installing Kali. So whenever they come into the classroom, they install a tool called Vagrant, and they just type Vagrant up. And then that gives them a fully up-to-date Kali installation that they can use for the labs. And so I kind of cover in the provision initial state and the YouTube video. That YouTube video actually talks you through how at Secure Ideas, I use that same environment of the automated Kali installation. I use that box that's fully automated in the background each month to do my actual pen testing. So that is how I use that automated Kali image being built in my pen testing whenever I do pen tests.
Now, I do want to speak to that real quick and say, hey, if you've never installed an operating system like that before from scratch, highly recommend doing that just to get the experience with it so you can understand exactly what we're going through. Us graybeards like me and Bill, we did that a lot back in the day. Like that's literally the only way to do this stuff. These new kids out there like Alex are like, oh, I can automate everything. Look at this, brah, brah, brah. So, I say graybeard because you can't see it. I can't grow one, but trust me, it's really gray, right? So, Alex, what else you got?
Yeah. So, lastly, Will Schroeder from Spectre Ops, he gave a presentation about how you can use OffSec Ops, which is like mixing DevOps and offensive security, to prepare for your engagements. So he actually talks through how they use like a Jenkins pipeline to actually build installation or the actual executables that they end up using in their red team engagements. So then they have that build process, but as part of that build process, they have it to where it'll slightly obfuscate it. So that way they can then test it. And this is all inside their pipeline. They can test it against Windows Defender and see if it gets caught. So they have this whole process set up to where they have the actual agents that are getting deployed for their C2 infrastructure, getting created, built, and artifacted based on which client it's going to be assigned to, and then actually tested to validate that they're not going to get caught by AV. So it's a really cool talk that he had done that at SoCon, which is the Spectre Ops conference, and the link for that video is there.
I like that a lot. All right, so we're at the point now. We're at time. We're trying to keep this as quick and short as possible. So, do we have any questions? Right, and I don't care if you're going to ask questions that make Alex cry. You're not going to make me cry because I can handle your questions. Right. Anybody got any questions? Bill, have you seen anything?
Nope, I think we're good for right now.
All right. Well, my memes to not go to waste. Questions. Oh, my host came down. Ask away. So, thank you guys for coming today. We really appreciate you showing up to take advantage of learning how to employ infrastructure as code for your red team or for your blue team. If you've never used it before, clearly this is something that you might want to be looking at yourself. I'm definitely going to be taking a much stronger look at it myself in the not too distant future. Again, my name is Aaron Moss, security consultant with Secure Ideas. Alex?
I'm Alex Rodriguez, security consultant at Secure Ideas.
The other guy that's on here with the beard that I can't grow is Bill at secureideas.com. If you guys have any questions for us about anything that we've discussed today or any kind of security related matters whatsoever, or if you just want to talk shop about something, please feel free to reach out with to any of us here at Secure Ideas. We'd love to chat with you about any of your security needs, any kind of consulting needs that you have. Or if you, like I said, you just want to chat with us, we've also got Professionally Evil Slack that you can join. I believe that's at professionallyevil.slack.com, or is it slack.professionallyevil.com? I can't ever remember. It's always, I always get it backwards. So it's one of those two.
You can just go to professionallyevil.com, and I believe there's a Slack invite there.
There you go. Bill, I think we're good, man. You want to?
I was going to say that's the easy way through. Yeah, this was a lot of really good material. And as you were going through, I'm glad you tied it back to Vagrant, because it's essentially a Vagrant type of setup, except for all of your infrastructure or for your cloud environment.
Yeah, love it. Absolutely. Repeatable and reproducible.
Yeah, I love the Vagrant image.